let's look at another example of standard deviation and what that means. So we've done a sample population here. In a certain area, we have sampled a number of trees and we've looked at their heights. And we found that there were 8 trees that were between 4 and 5 meters tall, 10 trees that were between 5 and 6 meters, 12 that were between 6 and 7 meters, and so on. So in total here, we sampled 104 trees. These were the frequency or the number of trees here, and this is their height. Now, when we take the average, the mean, and we're going to use this symbol because this is a sample population, the mean is 8 meters. So that is the average. Now, you'll also notice that this happens to be the median and the mode for this. Now we want to take a look at the standard deviation and the Z-scores. And you'll notice that we have done a frequency histogram, and it does follow the normal bell curve or normal distribution. So to do the standard deviation here, let's look at what x sub I minus the mean squared is for each of these values. We only have to do this once. We don't need to do it 8 times, even though there are 8 trees in this category. So here we have 4 is our value. Our mean is 8. That gives us 4 squared is 16. This is 5 minus 8 squared is 9. 6 minus 8 squared is 4. 7 minus 8 squared, and 8 minus 8 squared is 0. Now when we go back again, it will be similar values. 10 minus 8 squared is 4. 11 minus 8 squared is 9. And 12 minus 8 squared is 16. Now let's take a look at that, because here we know, before we are able to sum up all these values, in this category, for example, we know that there are 8 trees that are 4 meters tall. So we don't need to calculate this 8 times. What we can do instead is just multiply this by 8, and that gives us 128. Similarly here, we don't need to do this value 10 times because it will be the same each time, so we can just multiply that by 10. And we'll do that all the way down until we get all of our scores here. This will just be 0, and then you'll notice it's the same coming down here as well. Times 12 is 48, times 10 is 90, and times 8 is 128. Now, in order to get our standard deviation, we have to sum all of these scores. So this, remember, is from 1 to 104, and we're summing. I should put in what the mean actually is here, and that is 8 squared. And when we sum up all of these values, that happens to be 560. Now, because this is a sample population, our standard deviation is going to be the square root of 1 over 104 minus 1, because this is the sample and not a full population. And then we already have our sum here of 560. And so we'll take the square root of that, and this should give us a standard deviation of 2.33. Now I've just rounded that. There are many more decimal places, but we're just going to round that here. So what does that mean? Well, let's take a look at another just a bell curve here. And this is the mean down here, which we saw is 8. Now what this means is that within one standard deviation, 68% of our data lies. So that means between here, and remember our standard deviation was 2.33, so between here and 10.33, this is 34% of our data, and this is another 34%. This value here would be 5.67. So 68% of our data lie within this range, 34% on either side. Let's look at the next interval. So this is 2 standard deviations now. We're 2 standard deviations from the mean. And this value would be 12.66. And on this side, again, this is 2 standard deviations. And this value here would be 3.34. And we get this, remember, by taking 8 minus 2 times 2.33. That's 2 standard deviations away. Similarly, for this value, this is 8 plus our 2 standard deviations. Okay, and now we have one more, our 3rd standard deviation here. So this comes right out to the end. So now we are at 3 standard deviations from the mean. This value is 1.01. We can probably just round that to 1 meter. And over here, our last one again, this is 3 standard deviations. And this would be about 14.99, or we could round that probably to 15. And this again is 8 plus 3 times our standard deviation. This one was 8 minus 3 times our standard deviation. Okay, so now if 68% lie within 1 standard deviation, then 95% of our data lands between these two values, between 3.34 and 12.66. 95% of our data will land between those two values. And here, 99.7% will land between 3 standard deviations. So let's just remind ourselves again about our Z-scores. Now, our Z-scores correspond to a particular value. And let's say we had a value of 7. 7 would have a Z-score of -1 because it is to the left of the mean, and it is within 1 standard deviation. So I'm just going to draw a line here and put in all of our Z-scores. This one would be +1. Let's make this a better line. This is +2 and +3. This one here is -2. And this one is -3. So now we can say that any value within this range between here and here will have a Z-score of -3. Any value within this range will have a Z-score of -2, and so on. So those are our Z-scores.